What we're looking at now are the solutions to page 187, 11 through 19, and 24 through 30. And we'll get through as many of these as we can in the time allotted. First, the first couple problems, we have quadrilateral SLTM is a rhombus. Now, it's very important to read directions. When we have a rhombus, there's a whole lot of information that goes along with that. So first it says if angle 1 is 25, so we're going to put 25 right here. Find the measures of angles 2, 3, 4, and 5. Well, first, we know that the diagonals of a rhombus are perpendicular. So the measure of angle 5 right away is 90. And we also know that the diagonals are said to bisect opposite angles. So this angle here is bisected, and so is that one. So angle 2 is the same as angle 1, so the measure of angle 2 is 25. Now to find angles 3 and 4, we know 3 and 4 will be equal. But to find them, we need to use this triangle right here. We have perpendicular lines, we have a 25-degree angle. The three angles of a triangle must make 180 degrees. So 25 plus 90 plus angle 3, that's a 3, yeah, are going to make 180 degrees. So the measure of angle 3 is equal to 65. And so the measure of angle 4 is the same. Next we have, we replace these, and we say angle 1 is 3x plus 8, and angle 2 is 11x minus 24, and find the value of x. Well, we just said that those two are equal, so we say 3x plus 8 equals 11x minus 24. Subtract 3x from both sides, add 24, and all of a sudden we're looking at x is 4. Next we have angle 1 is 3x plus 1, and angle 3 is 7x minus 11. So here's 3x plus 1. So angle 2 is also 3x plus 1. And angle 3 is 7x minus 11. Now we know that we said earlier that the three angles in this triangle will make 180 degrees. So since we have 90 here, 3x plus 1 plus the 7x minus 11 should have a sum of 90 degrees because the acute angles of a right triangle are complementary. So we have 10x minus 10 equals 90, 10x equals 100, and up here, x equals 10. That was fun. Next, we have quadrilateral FLAT is a rectangle. Now again, looking at what we're given in the directions here, a lot of information can be concluded because we have a rectangle. For example, we know that the angles all here are 90 degrees. We also know the diagonals are congruent. Okay, so if we have angle 1 is 18, and we're asked to find the measures of angles 2, 3, and 4, well, first, we say in a rectangle, all these pieces end up being equal because the diagonals bisect each other and these diagonals are congruent. So angle 2 must also be 18 because we have an isosceles triangle down here. Now angles 2 and 3 have to add up to 90, so this angle here just has to be 72. And since these two pieces are equal, we have another isosceles triangle here. So angle 4 is also 72. So we have angle 2 is 18. The measure of angle 3 is 72. And the measure of angle 4 is 72. The next problem, we're told that FA is 27. That's the whole length of this is 27. Find LO. Well, we know that TL is going to be 27 as well, so LO is half of that. So we get 13 and 1/2. Next we have if TO is 4y plus 7 and FA is 30. Well, if FA is 30, then FO is 15, OA is 15, and TO we have 4y plus 7. So to find the value of y, we just set those equal to each other. 4y plus 7 is equal to 15, because these were already marked equal. 4y equals 8, and y is 2. Next, we're told that GM is a median of right triangle IRG. So that means this piece is equal to this piece. And we had a theorem that said if we have the midpoint of the hypotenuse of a right triangle, that point is equidistant from R, I, and G. So that means these three segments are equal. That might make everything solving here easier. 17, angle 1 is 32. We're supposed to find 2, 3, and 4. Well, we have an isosceles triangle here, so the base angles are congruent. We have a right triangle here, so these two have to add up to 90. So we get 58 for angle 3. So it's 32, 58. And for angle 4, we have another isosceles triangle, so that's also 58. And we're done. The next one, we have angle 4 is 7x minus 3. And angle 3 is 6 times x plus 1. Find x. Well, we just got done saying that we had an isosceles triangle here. So those are two base angles of an isosceles triangle. So we're going to set them equal to each other. 6 times x plus 1 equals 7x minus 3. And when we solve, we get x equals 9. And we sing and rejoice because we're done with that problem. Number 19. We say GM is 2y plus 3. And RI is 12 minus 8y, which let's find the value of y. Well, since GM is equal to RI, which is equal to MI, we know that GM is half the length of RI. So 2y plus 3 is equal to 1/2 12 minus 8y. Well, this is really easy. Okay, add 4y to both sides. Subtract 3. And you get y equals 1/2. So the next problem, we're asked to find RQ, SA, the perimeter of PQR, and the perimeter of SAT on a shape that was right here a second ago. Let me draw it. Okay, here's the picture that was given with this problem. And we're also told in directions that P and Q are midpoints of these sides. So this is equal to this, and this piece equals this piece. So I think it goes without saying that this is 10. And we're also told that RA is an altitude of the triangle, so we have a right angle right here. Now our first task is to find RQ. Now what I noticed about RQ is that RQ is a segment that connects the midpoint of the hypotenuse of a right triangle right here to the vertex of the right triangle itself. Now I'm going to do this in a different color so you can see it a little bit better. Here is the right triangle I'm talking about. And we have the midpoint that we're connecting to here. Oh boy, that was ugly. But one thing we know is that when we connect the midpoint of the hypotenuse, it's equidistant from the three vertices. So that means this length is the same as these two. So this is 10. Okay. Now if we look at the other side, this triangle right here triangle ARS, we also have the midpoint of the hypotenuse here. So just like before, the midpoint of the hypotenuse is equidistant from the three vertices. So this length is equal to both of these. So if we have 7.5 here, each of these is 7.5 or 7.5. So we have 7.5, 7.5. So when they ask for SA, we just say, oh, it's 2 7.5s, which is 15. Next, we say find the perimeter of triangle PQR. Well, PQR, if we find the perimeter, we just need to add up the three sides. We have 7.5 plus 10. All right, 7.5 plus 10 plus PQ. Well, you may have noticed that PQ connects the midpoints. PQ connects the midpoints of these two sides. So that means it's half of ST. Ooh. So ST, let me clear this out a little bit. So since ST has a total length of 25, PQ is half that, which is 12.5. So we say plus 12.5. So 7.5 and 12.5 together make 20. Plus 10 more is 30 for number 26. And then the perimeter of SAT, the whole thing here, is just 25 plus 20 plus 15. So we get 40 and 20 is 60 for that one. And that's the end.